Hello everyone, welcome back to my channel, The Quant Tutor. So today we'll be continuing with the June 2022 Pure Mathematics 1 paper, question number 7. Let's get started. So we are given an equation, right? Fx is equals to x plus 4 multiplied by x minus 2 multiplied by 2x minus 9, right? And we are also given that there's another equation here, which is basically fx minus p, right? So what fx minus p is essentially that it's this equation that we currently have and then minus p, okay? And what we know about this new equation, fx minus p, is that it passes through the point with coordinates 0 and 50. All right, so now first let's talk about what does it mean, y is equals to fx minus p. What we know is fx is this curve, right? So fx minus p is a curve that is basically going down by p units. Okay, because p is something that is outside the x, right? It's basically translating down. It's affecting the y-axis, while the x-axis remains the same. So our new curve looks basically the same as this curve, but it will basically be like that. Okay, I don't have the best drawing, but I hope you can understand what I mean. Right? And we know that this curve now comes down. Oops. So we know that this curve now comes down with a value of p. Okay. Now, what we also know is that this point, right, where the curve interacts with the y-axis is the point 0 and 50. Okay. So now what they have asked us in part A is find the value of the constant p. So we want to know that how many units did the curve fx come down by, right? To be able to form this new equation, y is equals to fx plus p, right? So what we need to know is we just need to find what is this value. Where does the old original curve fx intersect with the y-axis, right? So once we have that, we will get 0 and something, right? And then we basically get that something and subtract that with 50 to be able to get our p, right? So let's get started on this. So for us to be able to know where this original equation intersects the y-axis, right? The y-axis is essentially where x is equals to 0, right? So what we're going to do now is we are just going to say what is the point of y, right? So this is y, where x is equals to 0. So I'm going to replace all the x with 0, okay? And I'm going to write it like that. So 2 times 0 minus 9. And what I'm going to be left with is 4 multiplied by minus 2 multiplied by minus 9, right? And then I'm going to do minus 9 times 2 times 4 is going to give me 72, right? So now I know that this new point, now I know that this old point, has the point 0 and 72, right? And this point 72 came down by p units to become 0 and 50, right? So p is equals to 72 minus 50, which is equals to 22, right? So if I want to write my new equation, right, my new equation will basically be y fx. Fx is basically, I'm going to rewrite the equation above, right, our original equation, x minus 2, 2x minus 9, and then I'm going to follow that with minus 22. And this is the new equation that we have with the value of p. Okay, let's get to the next part. The next part gives us another equation, right? Gives us another equation that is dependent on the original equation again, right? So what it's saying is that this another curve is basically f x plus q, right? So all the x is now replaced with x plus q. And this curve passes through the origin 0 and 0. Okay, so we know that at the point where y is equal to 0, x is equal to 0, and vice versa. Now what they're asking for in part B is write down the possible values of the constant q. Right, so what we're going to do here first is we are going to take our original equation, right? I'm going to rewrite our original equation here. Sorry, let me rewrite it up here. Okay. So our original equation is equals to x plus 4 times x minus 2 times 2x minus 9, right? So we have our equation fx. Now, if I want to write now I'm going to rewrite this curve like that, fx plus q, which is basically replacing all the x here with x plus q, okay? And what I'm going to get is fx plus q plus 4, x plus q minus 2, and 2x plus q minus 9. Okay, there you go. So we have our new equation with x plus q. And now we know that this equation passes through the curve, through the origin, which is 0 and 0, right? So I know that this is my y, right? So my y is equals to 0 when x is equals to 0. So I'm going to say everything here is equals to x. Okay, all the x is equals to 0. So it's going to be 0 plus q plus 4, 0 plus q minus 2, and 2 times 0 plus q is equals, sorry, minus 9. Okay, and then what I'm going to be left with is, okay, I'm going to move here. Okay, I'm going to write here. So 0 is equals to q plus 4 multiplied by q minus 2 multiplied by, so 2 times q will be, so 0 plus q here is q, right? And then 2 times q will be 2q. So it's 2q minus 9. Okay, now this is what we have so far. I'm just going to rearrange what I have already written and make it a little bit smaller so that I have more space to write this. Okay, okay, it took a little bit too much. Let me try that again. Okay, I'm going to take this whole thing and I'm going to resize this and make it a little bit smaller, and I'm going to put that right here. Okay, and then I'm going to get this equation, and then I'm going to put that here. Okay, so right now we know that this becomes this, right? So this is where we have reached so far, and now we know that this is the equations that will give us the possible values of q. Now, based on our knowledge on quadratic equations, we know that we can say that all of these values can be equals to 0. It's possible that all of these values are equal to 0, which will give us the final value of 0, right? So I can say that q plus 4 is equal to 0, q minus 2 is equal to 0, and 2q minus 9 is equal to 0, right? So this will give us q is equals to minus 4. This will give us q is equals to minus 2, right? Because I'm moving it there. I'm moving it there. So the sign changes, right? So when 4 goes there to the right, it becomes minus 4. When minus 2 goes to the right, it becomes plus 2, right? And finally, for the last one, when minus 9 goes there, it becomes 9, right? So what will remain here will be 2q is equals to 9. And so because of this, q will be equals to 9 divided by 2, right? And there we have it. So our final answer here is the possible values of q are q is equals to minus 4, 2, or 9 over 2. So these are the three possible values of q, right? So now we are done with part B. Let's move on to part C. Okay, but before I move on to part C, I'm going to take this original equation with me because I don't want to spend time rewriting it and we will be needing it again. All right, so I'm going to paste that equation here. All right, now part C tells us find f dash x, right? F dash x is basically uh, differentiating this equation, right? But now if I look at this equation, I can clearly say that it's very hard for us to differentiate this equation. It's not in the form that we are used to, right? We want to make this a little bit simpler. So what we are going to do is we are going to expand this equation first, okay? So I'm going to start by expanding these two terms, okay? So just x plus 4 and x minus 2. So I'm going to multiply multiply x by this and then x by that, and then I'm going to do 4 by this and 4 by -2. Okay, so what I will get here is x squared, right? X times x. Now I'm going to do x times -2, which is minus 2x, and then 4 times x, which is plus 4x, and then 4 times -2 is -8, right? And then I'm going to multiply this one by 2x minus 9. Okay, so now I'm going to write this equation in a simpler form. I'm going to simplify this, right? Because minus 2x plus 4x can be consolidated. So I'm going to write this as x squared minus 2 plus 4 minus 2x plus 4x is plus 2x, yeah, and then minus 8. And then I'm going to multiply this one by 2x minus 9. Okay, now I'm going to expand this further. So the way I'm going to expand this further is I'm going to multiply x squared by this, x squared by that, and then 2x by this, and then 2x by 9, and then finally minus 8 times 2x, and then minus 8 times minus 9. Okay, so let's start doing this. Okay, so I'm going to write, I'll do all of them in a different color so you can all see how it's going properly. Okay, so I'm going to start with x squared. So x squared times 2x is going to be 2x cubed. X squared times minus 9 is minus 9x squared. Sorry, this is 2x cubed. Okay, and then okay, so now I'm going to move on to the next one, which is the green color, the green line. So 2x times 2x is plus 4x squared, and then 2x multiplied by minus 9 is minus 18x. Okay, and then finally now moving to the orange line, which is minus 8 times 2x is minus 16x, and then minus 8 minus 9 is plus 72. Okay, now I'm going to combine them. Right, let's add the ones that we can. Right, so I'm going to say 2x cubed is the only one that is x cubed. Now let's get the x squared added together. So minus 9x squared plus 4x is minus 5x squared, right? And then 18 minus 18x minus 16x is minus 34x, and then 72 remains as it is. Okay, so plus 72. Right, now our equation is so much simpler and so much more familiar with how we can differentiate this. Okay, so now we can go ahead and differentiate this and say that f dash x is equals to, so to differentiate the first part, we're going to do 3 times 2, right, which is 6x, and then 3 minus 2, which is squared, right? And again minus 5 times 2 is 10, and then 2 minus 1 is x, right? And then finally, anything that has an x behind just becomes a constant, and the constant just disappears. And so this is our final answer. Awesome. We're almost done with this question. Let's move on now to question number part D. Okay. And again, for part D now, I'm going to copy this equation with us since we'll be needing it there. Okay, so I'm going to copy this and I'm going to paste this here. Okay, now let's look at part D that tells us find the range of x which the gradient of the curve with equation is less than negative 18, right? So we know that a differentiated value, a differentiated equation gives us the gradient, right? This one basically is the gradient. So we want to know that what values of x is the gradient less than 18, right? So all we need to do is we need to do f dash x is less than 18, right? And we want to solve this equation. So I'm going to go ahead and write this, which is 6x squared minus 10x minus 34 is less than negative 18. Okay, so what I'm going to do first is I'm going to write a dummy equation here, which is going to be easier for us to solve, which is I'm going to remove this less than sign and just write this as equals to. Okay, so I'm going to rewrite this one as 6x squared minus 10x minus 34 is equals to 18. Okay, now we know how to solve this, right? So okay, when I write the dummy equation, I'm just going to move the 18 to the right, to the left. So I'm going to move this 18 here. So it's going to become minus 34 plus 18, right? Which is basically going to become minus 16. Okay, and I'm going to replace the less than with 0. Okay, so now we are just going to solve this normal quadratic equation as we normally do. So the first thing that I'm going to do is I'm going to simplify this as much as possible. So I'm going to take 2 out of here. I know that 2 is common here and 2 is basically going to go there. Okay, so I'm just going to divide all of these by 2. Okay, so divide this by 2, divide this by 2, and what I will get is 3x squared minus 5x minus 8 is equals to 0. Okay, and the way that I solve this, okay, because it's a bit more complicated to solve this, I'm going to use this equation called the quadratic equation. Quadratic equation. The quadratic formula, sorry. Okay, so the quadratic formula is basically minus b plus minus b squared minus 4ac divided by 2a, right? And I know that it's, so minus 3 is my a, this is b, so this is a, this is b, and this is c, right? So I'm just going to input these values in. So it's going to be minus 5. That does not look like a 5. Let me rewrite that. Plus minus b squared, right? So b squared minus 4a and c, and then I'm going to divide that one by 2a, right? So 2 times a. And when I do this, I will get my x value as either minus 1 or 8 over 3. Okay? Now I'm going to come back and I'm going to rewrite this equation as 6x squared. I'm going to rewrite this equation in the actual form now that we need, right? Which is 10x minus 16 is less than 0. So this is what we are actually trying to solve, less than 0. We know that if we use equals to, these are the values that we get. But what we need is actually less than 0, right? So we know that, let's get a number line up. So in a number line now, we know that if this is 0, right, we know that this is 8 over 3 about, and that this is minus 1, right? So now I'm going to put a random value in between here. I'm going to put a random value in between here. So let's take 0, and I'm going to input this into the equation, right? So if I put 0 here in place of x, and I put 0 here in place of x, what I'm going to be left with is minus 16, right? And we know that minus 16 is indeed less than 0. So is this correct? When I put the values in between minus 1 and 8 over 3 in this equation, I get minus 16, which is less than 0. And so this satisfies the equation, right? But if I put a value that is outside negative 2, so you can all pause this video now and try putting values that are lesser than minus 1, right? So maybe minus 2 or minus 5 or any values that are greater than 8 over 3, right? Which can be like something like 5, 10 or whatever, and put those in the equation and you check that does that satisfy the equation is less than 0, right? I'll tell you, so now once you've tried it, I'll tell you that no, it does not satisfy. So when you actually put those things into the equation, the final values will actually be greater than 0, which means that they don't really satisfy this equation. So when we write our final answer, we should write the answers that are in between, all the x's that are in between minus 1 and 8 over 3 satisfy the equation. So our final answer will be x is greater than minus 1 and x is less than 8 over 3. And that is our final answer and the end of this question. If you have any questions or any doubts or anything that was not clear, please feel free to write your questions in the comment box below. And if you like this video, please like and subscribe. I'll be back with the next question. See you guys.